Okay, let's do another example here. And this time we're not being asked to solve for the dilated or contracted quantity, right? We're actually being asked to solve for the speed of something, right? Okay, so what is the speed of an electron if it has a mass of 0.634 MeV? Its rest mass is 0.511 MeV, right? Remember, we can actually figure out by simple subtraction how much kinetic energy it has. We can just subtract that. The kinetic energy is, what is it? It's 0.123 million electron volts. That's how much more mass it's gained. I'll talk more about that later. Okay, let's just solve this as a simple thing, right? So this is our dilated mass. This is our rest mass. Moving mass, rest mass, right? The formula is simply dilated mass is rest mass or proper mass, right? Over the square root of 1 minus v squared over c squared, right? Now I'm going to solve this without putting the numbers in, because when you solve it, you end up with a very beautiful thing that you'll never forget. Okay, so the first thing I'm going to do is I'm going to rewrite this as, I'm going to stick this guy, down here and this guy up here, okay? And I end up with m naught, which is the small thing, right, over the big thing, the dilated mass, right? And I'm going to square that, right? That equals, well, we'd have just the radical on the other side, but since we've squared it, we don't have the radical, right? We go 1 minus over c squared. So I did a lot of things there, right? I put this guy down there, put this guy up there, I squared both sides. I end up with this, right? Okay, now the next thing I'm going to do is I'm going to trade these terms. I'm going to put this term over there, this term over here, right? And so now that looks like this. V squared over c squared equals 1 minus m naught over m, and then that's, of course, squared. Right? You just trade those guys, trade places, right? And then, of course, I think the next thing to do is to get v all by itself, and I'm going to square root two things at once, right? So I'm going to put the c over there, multiply it by this side, and I'm going to square root both sides, right? And I end up with v equals c times the square root of 1 minus right? And this is kind of beautiful because it looks kind of like this. In fact, this formula right here, this is 1 minus small velocity squared over big velocity squared. And when we solve it for the velocity, we get the velocity as c times the square root of 1 minus small mass squared over big mass squared, right? All solutions for v from the Lorentz factor, if you ever solve for v, it's always that v is equal to c times the square root of 1 minus small squared. My pen is not liking this MacBook Air. Small squared, that's an A. Over big, let's draw slow. Seems like the more things I draw, the slower it gets. V equals c times the square root of 1 minus small squared over big squared. That's the solution. So I still haven't gotten the answer, right? So let's get the answer here. Okay, so it should be c. V is going to be c times the square root of 1 minus, small as this guy, 0.511, squared over the big square. This is the dilated mass, will be the big guy, right? Okay, so if I do this, and I'm not even going to put the speed of light, I'm not going to put 3 times 10 to the 8th, I'm just going to find what's in the radical. That's all I'm doing here. So I'm going to go square root of 1 minus 0.511 squared divided by 0.634 squared, right parenthesis. And I get 0.5919 C. If I do it slowly enough. Which I guess with 3 sig figs would be this. So just remember, if you ever have to solve for v, it's always c times the square root of 1 minus small squared over big squared. no matter what the situation is. That's what it always is. Of course, big 1 minus the square root of big squared over small squared is, well, it's the imaginary.